Okay, so we're going to start at the beginning. We're going to start classifying matter, right? Chemistry is the study of matter and how we change it. So what is matter? Matter is anything that has mass and takes up space or has volume. Okay, so anything that has mass and takes up space is considered matter. And when I say it has mass, that just means it has particles in it. Mass is the quantity of matter in an object. Okay, so matter is generally comprised of these three categories: gases, liquids, or solids. You won't find very commonly matter in different states, but there are different states. There's plasma, there's Bose-Einstein condensate, but we're not too worried about those. Most things are going to be either a gas, a liquid, or a solid. Okay, so you should be able to look at a picture and tell me if that is a picture of a gas, of a liquid, or of a solid. A solid is always going to have a definite shape and a definite volume, so like a block of something, as you can see from the picture. A liquid is going to be fluid. It is going to have a fixed volume, meaning it's always going to take up the same amount of space, but if you put it into a container, it's going to fill up the bottom part, right? So it's not a fixed shape. If it's 20 milliliters, it's 20 milliliters. It's just going to fill the bottom of whatever container it is in. Okay, and a gas has neither a fixed volume nor a fixed shape, meaning if I put it into a container, it's just going to fill that whole container. So if I put it into a 20 milliliter container, the gas has a volume of 20 milliliters. If I put it into a 50 milliliter container, it has a volume of 50 milliliters. So a gas does have a specific number of particles, but no fixed volume and no fixed shape. Okay, so changes between any of these three states of matter, gases, liquids, and solids, are called physical changes. Any physical change is something that doesn't affect the chemical composition. So for example, water, whether it is a gas, water vapor, liquid, water, or solid, ice, it still has the chemical formula H2O. Okay, so changing phases is a physical change. Okay, so we're going to move on to classifying matter. Yes, it can be classified as a gas, a liquid, or solid. Those are the states of matter, but we can also classify it as pure substances or mixtures. So all matter can be classified as either a pure substance or a mixture. Most matter is a mixture. Okay, they have different particles, different combinations of pure substances. So anything that is comprised of more than one element, more than one compound, and we'll talk about how we classify those later as well. So mixtures then can be broken down into two different categories. There are homogeneous mixtures and heterogeneous mixtures. So a homogeneous mixture is where the parts of the mixture are in the same state, so like all gas, all liquid, or all solid. There's no visible boundaries. It is uniform throughout the mixture. So if I'm looking at a homogeneous mixture, I can't see the different parts, okay? So an example would be air. You can't see the different parts of air, though there are molecules of nitrogen, oxygen, water vapor, carbon dioxide. There's a whole bunch of different things in the air. So it is a mixture, but you can't see the different parts. So it is a homogeneous mixture. It has a smooth consistency throughout. You can think of it that way. Okay, tap water is also a homogeneous mixture. If you get water out of your tap at home, it has H2O in it, of course, but there's also other minerals in there. There might be fluoride that's added to treat the water. There are all kinds of other things in tap water, not just H2O. Now, if it was distilled water or just H2O, then it would not be a homogeneous mixture, and we'll talk about what that is in a bit. Okay, so the opposite of a homogeneous mixture would be a heterogeneous mixture. So this is one that is not completely uniform. You can see the different parts. Okay, so for example, chocolate chip cookies, right? You can see the different parts in a chocolate chip cookie. Blue cheese, you can see the different things in blue cheese, or dirt. One that might not have come to mind is milk. Milk is actually a heterogeneous mixture, specifically because if you do look on a smaller level, you can see the different parts. There are different molecules in milk. It's kind of like a colloid, and in that the other parts are like suspended. If you let milk sit for a really long period of time, it will separate. You would get a heterogeneous mixture. So if something has distinct layers or different parts, it's going to be a heterogeneous mixture, or if it has different phases, right? Homogeneous has same phases, heterogeneous has different phases. So all mixtures, so this includes homogeneous or heterogeneous mixtures, can be separated by some type of physical process. Note I said physical process here, not chemical process. So I should be able to separate a homogeneous or a heterogeneous mixture by its parts, either by pulling them apart, or sometimes it's a little bit more complicated than that. Two other ways to separate a mixture would be distillation. So you've probably heard of distillation before, right? If you get distilled water, how did that happen? Well, it actually is a method of separation based on volatility. And volatility is how easily something is converted into a gas. So if something is easily converted into a gas, it will turn into a gas, and then we can recondense it and collect it. So this picture over here is actually a distillation apparatus. So if I start, this is where I'm starting with this bulb over here, this flask, with salt water. Okay, so salt water is a type of mixture. If you have salt dissolved in water, you cannot see the different parts. This would be considered a homogeneous mixture, or a solution. That is another word for a homogeneous mixture, a solution. So if I have a solution of salt water and I heat it up, okay, water is going to boil much faster than salt, right? Salt has an extremely high boiling point. I'm not going to be able to melt or boil salt with a Bunsen burner, but water, I can. So what's going to happen is I'm going to heat it. Water is more volatile than salt, meaning it will turn into gas more easily than salt. So as it heats, water is going to turn into steam or water vapor. It's going to go up, and then it's actually trapped. It goes through what's called a condenser. So there's actually cold water going around this condenser, and as the steam goes through the condenser, it actually turns back into liquid, and we can collect it over here. So that's how a distillation apparatus works. Okay, heat it up. The thing that's more volatile will boil and turn into steam. Then we can condense it back down and collect it. And then we would be left with the salt still over here, because it won't ever get to a temperature high enough to actually heat it and collect it. So this is one way to separate a mixture, usually a liquid mixture. Another method of separation would be crystallization. So if I wanted to actually get the salt out of water, I could let it sit out and crystallize. As the water evaporates, the salt is going to stay there and crystallize. That's how I could separate them. But if you have different concentrations, so meaning a different amount of stuff dissolved in other stuff, and we'll have a whole unit on that, you could get some to crystallize or turn into a solid, so you could separate it out of a solution. So there's just two of the multiple methods of separation. You will do more methods of separation in lab this semester. Okay, so we talked about mixtures. Now we said mixtures are made of pure substances. So what are pure substances? A pure substance is something that has a fixed composition. All of the particles look identical. So like water we were talking about earlier, if it was just H2O and all of the particles looked like H2O, it would be a pure substance. So just like mixtures, pure substances can be broken down into two categories as well. All pure substances are either going to be elements or compounds. Okay, so an element is something that cannot be decomposed. It cannot be broken down any further, no matter what process you do to it, except for nuclear, but that we'll talk about later. So these are actually things that are listed on the periodic table. Now, no, you guys will not have to memorize the periodic table, but you will always have access to one. So something is listed on the periodic table, it's an element, it's pure element. Carbon, helium, anything that of those 118 elements on the periodic table are considered elements. Okay, if it's just that, it is a pure element. Now, things can also be compounds. This is actually going to be the most abundant of pure substances, are compounds. And that's when you have two or more elements that are chemically combined, which really means that they are bonded together. So we've been talking about water, H2O. I know you all know the formula of water. That is a compound because it's H2O, meaning two hydrogens and one oxygen bonded together, and every single particle looks like that if you have a sample of pure water. Okay, same thing is true of salt. Salt is sodium chloride, NaCl. All of the particles look the same. They're an Na and a Cl. And carbon dioxide. All the particles of a carbon dioxide sample look the same. It is one carbon and two oxygens bonded together. Okay, so if all of the particles, which are the smallest piece of substance, look exactly the same, it's going to be a pure substance. So it's either an element or a compound in that case. Okay. Now, the only way to break down a compound, I already said you can't break down an element, you can break down a compound, is through some type of chemical change. So we said up here that mixtures can be separated by physical processes or physical changes. Well, compounds can be separated by chemical changes. Chemical reaction is the only way to separate a compound. So for example, if you have liquid water, I can undergo a process called electrolysis, or essentially running a current through it, and get it to separate into its two elements, hydrogen and oxygen. So that's what this is actually showing here. Once I get them to separate, I get H2, that's how hydrogen exists, and O2, that's how oxygen exists over here. That is one method of chemical separation. Okay, so if you're actually trying to separate the elements in a compound, that would be some type of chemical reaction. Okay, so this is just a recap. I like this flow chart. All matter can be broken down into two categories. It is either a pure substance or a mixture. And if it is a pure substance, it's either an element or a compound. If it's a mixture, it is either homogeneous or heterogeneous. So this could be a really handy review to look back at later. Okay, so I have example number 1 here, and I will have you try this before I give you the answer. It says, identify each substance as a compound, an element, a heterogeneous mixture, or a homogeneous or homogeneous mixture, also known as a solution. Okay, so give this a try in the examples, and then I will share the answers. Okay, so you should have gotten that filtered tea is homogeneous. Once you filter out your tea, you just have your tea, you cannot see the different parts. Freshly squeezed orange juice should be a heterogeneous mixture. You can see the different parts. There's going to be pulp floating in there. A compact disc, you can tell how old these examples are. Nobody really uses compact discs anymore, but a CD, I would consider a heterogeneous mixture because you can see different distinct lines in it. Aluminum oxide, which is a white powder that contains a 2-to-3 ratio of aluminum and oxygen atoms. What that means is the formula is 2 aluminums and 3 oxygens, Al2O3, always. So if a particle or something has a fixed ratio, i.e. always 2-to-3, or for water, it's always 2-to-1, it's going to be a compound. So that would be a compound, aluminum oxide. And selenium can be found by itself on the periodic table, so that must mean it's an element.